I'll go here over the piece of the file that you have already seen. So there are three properties I will describe of such an area. The first one is that the area is going to be 0 if the two vectors are proportional, if they are collinear. Right? If one is just longer than the other but has the same direction, then there is no area between them, and the area is 0. So that's something everybody can agree upon, right? Now the second property is that this area is proportional to the length of any of the two vectors. Basically, if you take this side and you double its length, then the whole area will be doubled, right? In general, if you multiply that side by some coefficient, the whole area should be multiplied by the same coefficient, right? So that's something that is easy to see geometrically. And then the last property I want to convince you about is distributivity. So now, as you think of the area being a product, right, then it makes sense to ask, well, is that area kind of product distributive? If it is, then area can be considered as a product, or it can be thought of as a product. And, well, is it really true that, let's say, for this one, let's check that formula, that area of u plus v and w is the same as sum of those two areas. So let's check it geometrically. What's the left-hand side? This is u plus v, that is w. The area is this parallelogram, the pink one. Okay? And let's see what the right-hand side is. The area on u and w is this parallelogram. And the way to see the area on v and w is to imagine v being here. And remember, it doesn't matter where we draw the vector. It's just a different picture of the same vector. So think of this as v. Think of that as w. And then the area on v and w is going to be this parallelogram. So the right-hand side ends up being this parallelogram plus that one. And the real question is the sum of these two areas equal to the area of pink parallelogram we begin with? Well, and yes it is, because again you can cut out this triangle and bring it down, and it will fit in so that the sum of the areas of the two parallelograms is exactly equal to the area of the pink one. So again, there is no limiting process, no infinite process. Everything is finite step procedures. Very convincing that the formula holds true. And you can check the second formula, drawing a similar picture. So distributivity holds for area. Okay? And that means that you can think of area on two vectors, area of a parallelogram, being sort of a product. Right? And for the rest of today's class, I will show you 3 applications of that idea.